Hello and welcome. In this video we will learn how to generate toolpaths for incremental sheet forming or ISF. Toolpaths are used by a computer numerical control or CNC machine. A CNC machine uses coordinates generated from a toolpath to produce incrementally sheet formed parts. The aim for a toolpath is to produce a part with the best surface finish in the shortest time possible. To achieve this, it is necessary to understand the key toolpath parameters and how they affect the formed part. Key toolpath parameters include the type of toolpath, the tool shape, step depth, scallop height, and tool feed rate. There are numerous paths a tool can follow to incrementally form a part. Depending on the desired surface finish, some toolpath patterns will be preferred to others. For example, a spiral, or sometimes called helical toolpath, may be preferred to a slice toolpath. A spiral toolpath gives a good surface finish because the tool is always in contact with the sheet material and follows a gradual pattern, whereas a slice toolpath will leave a visible surface scratch where the tool moves down after each pass. For ISF, different forming tools can be used that vary in both shape and size. Determining the type of tool to use is beyond the scope of this video, but it is enough to know that different tools can produce different surface finishes and forming angles. Therefore, the software used for the toolpath generation needs to be told the type of tool that will be used by the CNC machine. The step depth is the vertical distance the tool will move down after each pass, whereas the scallop height is the height of the surface profile after the sheet metal is formed by the tool for each pass. The smaller the step depth or scallop height, the better the surface finish, but the process will take longer. Using a larger scallop height would reduce the time taken to form the part, but the surface finish would be worse. If each pass has a constant step depth, then the steeper regions will have a smoother surface finish, since they will have a smaller scallop height according to the geometric relationship between the tool and sheet metal. Finally, the tool feed rate determines the speed at which the tool will move during the forming process. The feed rate has a small effect on surface quality and friction compared with other parameters. Of course, a faster feed rate will form the part quicker. The optimal feed rate is material dependent, but a typical value would be between 2000 and 4000 mm per minute. An example toolpath can be generated using Fusion 360 software. It is always important to check for any errors in a toolpath before editing and exporting the toolpath to a CNC machine. The tool will follow the blue line as shown in this simulation. If no errors in the simulation can be found, then the toolpath is ready to be exported as code that can be read by a CNC machine. If any errors are found, then the toolpath parameters will need to be adjusted. All the unique toolpath considerations for ISF have now been addressed. Thank you for watching.